A few videos earlier, we were trying to integrate one polynomial over another polynomial in the case of the degree of the numerator being greater or equal to the degree of the denominator. So, for example, we were trying to integrate this. But in order for us to integrate this, we needed to go away and do our long division, because in the case of this, in the case of the degree of this being greater than the degree of the denominator, we needed to use long division to break this up. So now that we've spent some time on long division, let's return back to this problem and let's try and integrate this now. So we are now going to try and integrate this. So to integrate this, multiply this out. So this times this, this times this, this times this, and this times this. That will then give us this. And now we need now in the case of the degree of this is greater than the degree of this, we need to use long division. So now we need to use long division to get this divided by this. Okay, so we need long division to get this divided by this. That would be us doing this. So this is us using long division. So now this thing divided by this thing. So using long division, the answer would be this, and this would be our remainder. Okay. So what that means is, hang on, going back to here. What that means is we can rewrite this as this. Hang on, bear with me. We can rewrite that thing there as this thing plus our remainder. This is our remainder. Okay, so if you look back at our long division here, so this divided by this is equal to this, and this is our remainder here. So hang on. So this divided by this would give us this, and then this is our remainder. Okay, so what it's saying is that we can rewrite this as this. Okay, so hang on. So now look at this. Factorize this back again, so that will take us back to here. So we can rewrite this thing here as this thing here. So what that means is that if well, hang on. So now we now need to take care of this. Okay, so now notice that the degree of this is less than the degree of this. So we can use our method for cases where the degree of this is less than the degree of the denominator. So now let's try and break this up. So just looking at this only, okay, just looking at this only. So hang on, let me go back one step. We were trying to integrate this, but we can rewrite this whole thing here as this. So it was this, and this was our remainder. This was our remainder. But now we need to tackle this thing here. So let's break this thing up. Let's just leave this for the time being. We will come back to this. But now let's try and settle this thing for the time being. So looking at this thing only, looking at that thing only. So that's this here. So now rewrite this in terms of this plus this. So we've done this before. Looking at this, let's try and work out A now. So looking at this, times both sides by x minus 1. So by x minus 1. So these two will cancel out. This thing here will become this, and then this thing here will become this. So now, in order to find A, we need to let x equals 1. Okay, because when you let x equals 1, this thing here will become 0. So this whole term here will disappear. So A will be a third. Okay, now looking back at that thing again, looking back at this again, now we need to evaluate B. So to evaluate B, times both sides by x plus 2. So when you times by x plus 2, this side here will become this, times by x plus 2. So this thing here will become this thing here. When you times by x plus 2, these two will cancel out, leaving you B. Now to find B, let x equals negative 2. So let x equals negative 2, and then this whole thing here will become this. So B equals this thing here. B equals 8 over 3. Okay, so now now we've got to this stage here where this thing equals this plus this. Okay, so going back to the original, this was our ultimate aim here, to integrate this. But to integrate this, long division would give us this plus, well, thinking about this, looking at this here, we can rewrite it as this whole thing here. Okay, because we've just used, if you look at this here, this bit here is this bit here. Okay, but don't forget, we were at this point here. We broke it up into one fraction plus another fraction. So this bit here is this, and this here is this. Okay, so if you want to integrate this, then you can actually try and integrate this instead. So now integrating this would give us this. This here is easy to integrate. This here is easy to integrate. So now rewrite this as this, because a third is a constant, so you can take it out. This here is a constant, so take it out. So now integrating this and integrate this would give us this. So overall, the answer would be this. Okay. So as a just to double check our work, if you get a graph plotter and plot this, so that's this red line here. Okay. So if you get a graph plotter and plot this, it will give you the red line. Now this was what we were trying to integrate earlier. So if you integrate this, it will give you this. So what that means is that if you differentiate this, it should give you this thing here. So as a way of double checking, get a graph plotter, plot this, get a graph plotter and plot this. So now looking at the red line, if you differentiate this, it should give you this. So looking at the red line, imagine you are here. Now you're going downhill, 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 downhill. So the derivative of this should be in the negative realm. And it is indeed in the negative realm, because it's negative, negative, negative. And then now looking back at the red line, you're here at the moment. You're going down, negative, negative. And the gradient gets really, really steep now. So looking at the derivative, you can see the gradient's getting steeper and steeper in the negative realm. Now looking back at the red line, remember, we're trying to confirm that when you differentiate this, it will give you this. So just a trick to double check our answer. It's not perfect, but if you get something crazy, then you can pick it up. So now looking at the red line here, looking at this, imagine you're here now. You're going uphill, 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 uphill. So the derivative should be in the positive, 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 positive. So the two correlate with each other. So now looking at this here, somewhere in here there, well you can see that it's well, looking at this, if you look at the derivative of this, it does indeed give you this. Because if you look at this here, let's say looking at the red line, if you're here, you're going uphill, 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 uphill. So now looking at the derivative, you're in the positive realm, positive realm, positive realm, positive realm. Well, the two here, I hope you can see from the graph that if you look at the derivative of this, it kind of gives you this thing here. So it's an indication that our integration is correct. Not perfect, but it's an indication.